All right, today we're going to do 11.6. 11.6 is adding and subtracting rational expressions. Today we're going to add and subtract rational expressions with like denominators. We're going to add, subtract rational expressions with unlike denominators. Oh no, those are going to be the tough ones. Okay, because we're going to have to get that common denominator. That common denominator is the most important part. If we don't get the common denominator in there, we will not be able to add fractions. All right, so like I was saying, we have to make sure we have common denominator. The first ones, they do really nice. They have 5n divided by n plus 3. Oh, check it out, new marker. 15 divided by n plus 3. So look at this, we have common denominators. So just like any fraction, we can add the numerators. So we have 5n plus 15 over n plus 3. Remember, these are groups, so we cannot just randomly cancel stuff. Okay, this is a group, so I can't just cancel these n's. I can't try to simplify that because this is a group, this is a group. Cannot simplify groups like that. That addition sign in there messes that up. So we look at this and say, well, what do I got to do? Oh, I got a 5 in common. I can factor that out. So if I factor out a 5, what am I left with? Here, n. If I factor a 5 out of here, that's 3. That's what we wanted. So we got n plus 3 divided by n plus 3. This is a group, this is a group. Cancel. So we're left with 5. So 5 is our final answer. So just by simplifying that, we could get all the way down to 5. Pretty easy. Or 5 over 1. But we always know that 5 over 1 is the same thing as 5. Ooh, that new marker is a little bit harder to erase. All right. Wow. Okay. Example number 2. Looking at that one there. Oh, they already have it set up. It's pretty nice. So we have 3m minus 5 divided by m plus 4 minus 4m plus 2 divided by m plus 4. So we have the common denominator. What we're going to have to do is we're going to have to subtract the numerators. The biggest thing is here, we're going to have to distribute through this negative. Watch that. We can't just subtract the first term. This is an entire unit. So if I change the first part of this unit, I got to change the second part of this unit. So I got to distribute through that negative. So I could say it's like plus -1. So I'm multiplying this all by -1. So if I be able to draw up the parentheses, minus. There we go. Now I can just go ahead and when you get really fancy, I know you guys can't do that with your stuff. Cheating it. Okay, so I have 3m. Can't subtract there. I can subtract there. So I have -m. I have -2 and I have -5. -2 and -5 is -7 divided by m plus 4. So I have this right here. Do I see anything that cancels? Oh, that's it. No, the m's I can't do that because that's a group. That's a group. Those do not cancel. Will not do. So I'm really done. The only thing I can maybe change is if I don't like that minus, I could say negative m plus 7 over m plus 4. And I put the minus outside. So I factored a negative out of here. Could have also factored a negative out of here and had negative m minus 7 over negative out front, negative m minus 4. So all I did is just change all the positive signs to negative signs. So it's like I factored out a -1 right here. I put it right here. If I put that back in, I end up the same thing. Remember, anything I do, I have to be able to reverse it. If I can't reverse it, I didn't do it right. Always watch that. So that's example number 2. Example number 3. Ooh, we have inverse denominators. Wow, I'm going to pause this so I can try to get that erased. Boom, it's magic. Got it all erased. We're ready to go. All right, next problem. So we're looking at example number 3 here. Example number 3, we're looking for common denominator. Man, those common denominators, they look really close, but they're not common. Because here I have a positive n, here I have a negative n. Here I have a -4, I have a positive 4. So how can I do that? Ooh, just like I did in the last problem, I'm going to pull out a negative here. I'm going to pull a negative out and change this plus to a minus. I'm going to change these. So I had a minus n before, so I have positive n. I had a plus 4 before, so it's going to be -4. Same thing now. Yay! Now I can subtract the numerators. I have 3n minus 6n over multiples, so 3 n's minus 6 n's. The n's stay there, so I have minus 3 n's over n minus 4. Woo! That worked out nice. Double check the book. Dun, 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 dun. Yes! We have the same thing. I could also factor out a negative right here, and I would have got the same thing. So just remember kind of how we did that. It's just how do you like it seen? Okay, whatever direction you see it, that's fine, but just make sure if you factor out a negative out of here, you factor a negative out of there. You cannot pick and choose. You have to be universal. Next one, example number 4. They're asking to find the least common multiple for each pair of polynomials. Okay. So I have 6x and 4x cubed. This is what I have. So I'm trying to find the least common multiple. Okay. So what is in common with all of them is really what I'm looking for. Right? If I look at this, I say, well, I have 6. I have 2 times 3 times x. Okay. And if I look at this, I have 2 times 2 times x times x times x. Okay. All I did is I factored out to its basic terms. Okay. Factor everything to their basic factors, and I look for the pairs, right? Okay. If I already have a pair of them, I don't need it, right? So this one needs to be multiplied by 3. This one might need to be multiplied by another 2, and this one needs to be multiplied by a couple x's, is what I'm seeing. Okay. So look at this one. Like I said, I need to multiply by 2. I need to multiply x by x, this one here, so that way it all matches up. I need to multiply by 3. I think I'm good. Okay, so if I multiply all this back out, I end up with 12x cubed. Over here, I end up with 12x cubed as well. So we look at this, and we find least common multiple of, whoa, should be 12, not 16. Ah, it's going to be 12. I don't want to use. Not when I start with red. Should be a 12x squared there. Okay, and so this is the least common multiple. We looked at it and said, okay, this would be the best one to do. You might be asking, why would we do that? Man, duh. You know, that's pretty easy. Ugh. All right. But then we look at part B, and part B is a little more complicated. So we have n squared plus 5n plus 4. And plus 4. 5 g's. Yeah, 4. And then we have n plus 1 quantity squared. And we're looking at, they want to know what is the least common multiple of this. And so we're going to look at this and say, well, we got to factor it. So this tells me the signs are the same. This tells me they're both positive. 2 numbers multiplied together give you 4, and they add together to give you 5. N plus 5, or n plus 4. I got 5 stuck in my head. And n plus 1, which is good because this one here is n plus 1 times n plus 1. We want to make sure everything is accounted for. So we need to multiply this one by n plus 1. And we need to multiply this one by n plus 4. Remember, we do not have to have them in a certain order because it is okay. Any order that works, it's multiplication. So we look at that and say, least common multiple is right there. If we want to rewrite it, we could say n plus 1 quantity squared times n plus 4. Okay, we wouldn't rewrite it beyond that. We would not want to distribute through, or FOIL these things all out. This is what we want. Least common multiple is right there. Now we find out why we're looking for the least common multiple. So we're looking for that denominator. Okay, that denominator. Ooh. Wow. So to do this, we have 3t plus 2 over t squared minus 2t minus 3. And they want us to add t plus 1 and t plus 3. Or t minus 3. So we have that. Ooh, we got to factor this. So we have 3t plus 2 over t. Tells me the signs are opposite. Tells me the bigger one's negative. And so t plus 1, t minus 3. Yep. Plus t plus 1 over t minus 3. So we're looking at common multiple, least common multiple. Well, we have the t minus 3. This one over here needs a t plus 1, parentheses, t plus 1. And so we put it here. We also have to put it up here. That's that well-chosen 1. So I can't just put it here. I have to also put it up there. So I'm multiplying by 1. That would cancel out, and I'm fine. Hey, looking at this, they're actually asking us to add it together. I want to see where they're going to go with this before I do a whole bunch of fun work. So I have this. I'm going to have to square that out. So 3t plus 2 plus t squared plus 2t plus 1, remember FOIL, over the, and then this is not going to be the same. The best way to write is t plus 1 times t minus 3, just in case something works out funny that we can cancel it out. So combining like terms, t squared, 5t plus 3 over t plus 1 and t minus 3. Tells me the signs are the same. Tells me they're both positive. Two numbers multiplied together to give me 3, and they add together to give me 5. They don't exist. So therefore, I am done. I could distribute this one through, and so that way they look the same. It doesn't matter either way. That's the hard thing with math is say, do I stop here or do I FOIL this thing out? Either way, it will be acceptable. You know, this is prime, so that way I don't have to really worry about it. T squared minus 2t minus 3. So this would be okay, but you know, if we're factoring down to terms, this is a prime polynomial. These are now prime after that, after I factor them down. So this is probably the best way to leave them because then this prime divided by primes. So yeah, ooh, hang gliding. Example number 6. For the first 5,000 meters, a hang glider travels at a rate of x meters per minute. Due to strong winds, it travels 6,000 meters at a speed that is 3 times as fast. All right, so this one here, we have to kind of plan it out. So the formula is equal to d equals r times t, or t is equal to d divided by r. Okay, so we're going to have 5,000 divided by x, and 6,000 divided by 3x. Because we have the normal conditions, and then we have to add the airspeed to it because of the wind blowing us. So once again, 5,000 divided by x, and the other one's going to be plus 6,000 divided by 3 times the speed. And that's what we're trying to combine together. And so I need a 3 over here, so I need to multiply by 3 over 3. So I have 15,000 plus 6,000 over 3x. Now once I distribute that through, I have that common denominator. So I go 15,000 plus 6,000 is going to be 21,000 divided by 3x. 3 does go into 21, like 7 times, give or take. And we still have the zeros on there. So it's 7,000 over x. So whatever the normal speed is, that will be our solution. There we go. Pretty straightforward, pretty simple. So 5,000 divided by x, that's probably our hardest thing that we have to do is set up these equations here. Once you get those set up, ready to rock and roll. If the hang glider is flying at a rate of 600 meters per minute for the first 5,000 meters, find the total amount of time the hang glider is flying. So this one here, all we have to do is put in 600 here. So we have 7,000 divided by 600, and so it's going to be 11.7. So they just applied it. All right. Any questions, comments, concerns? Let me know.